Hi, this is lesson 1.3, Properties of Graphs and of Functions. What we're going to do for each of these functions that we see here is we're going to be 1, finding the domain and range, 2, finding the zeros and y-intercepts, 3, finding the intervals of increase and decrease of the function, 4, we're going to be looking at any discontinuities and asymptotes, 5, we're going to be looking at its symmetry, if it's even or odd, and 6, we're going to be looking at the end behavior. Okay, so what we're going to do is we're first going to just start with the basic things of the domain and range. And so this is the first function that I'd like you to draw into your graph on your student worksheet, your student handout. So this is the graph y equals x. Okay, and so what we want to do is first of all look at the domain and range. Okay, so what's the domain of y equals x? X is an element of all real numbers. The range, y is an element of all real numbers. Then we'll take a look at the zeros and y-intercepts. Okay, so zeros, x equals 0, and the y-intercept, y equals 0. Please make sure that you pause every time I have a little pause here. You pause the video so that you can actually write in the answers before I do. Intervals of increase and decrease. What we look at when we're looking for that is we take a look at the graph and we go to the leftmost point of the graph, and as we go across from left to right of the graph itself, not the grid, but the graph itself, as we go from left to right, we see in this case it's increasing. Okay, so interval of increase, and I just give a little short form like that. Interval of increase is, and I'll use this form, negative infinity to infinity. Or you could also write negative infinity less than x less than infinity. And interval of decrease, and there is none. Okay, discontinuities and asymptotes. Okay, there are none. And for part 5, which is symmetry, even or odd, we take a look at that, and even symmetry, that is when the graph is symmetric about the y-axis, and odd symmetry is when it is symmetric about the origin. Okay, so if it's symmetric about the y-axis, if we could flip this horizontally, the graph would lie back on top of itself again if it were symmetric, if it had even symmetry. If it's odd symmetry, then if you were to rotate it 180 degrees about the origin, or do two reflections, one in the y-axis and then another one in the x-axis, if the graph were to lie on top of itself, the original function, then it's got odd symmetry. Okay? So a way to do this is we've got f of x equals x. So we'll substitute in negative x, and the negative x, that's a reflection in the y-axis if you're talking about transformations. So if these two are equal, if f of x equals x and negative x, if those two are equal, then it's even symmetry, but it's not, so it's not even. So then what we do is we take that and then we multiply it by negative x, and we get x. Here we see that that would then be, of course, a reflection in the x-axis, in terms of our transformations. So we end up getting the original function again. So that means that it is odd symmetry. And for part 6, end behavior, we take a look at what happens to the graph as x gets really, really big. Positive towards positive infinity, and when x gets really, really big, negative towards negative infinity. So we see here as x approaches infinity, y also approaches infinity, and as x approaches negative infinity, y approaches negative infinity. Okay, so that's those are the end behaviors of the graph. Now what I'd like to do now is transfer that information onto this table. And so we'll take I don't have a ruler, I apologize profusely, and I just knocked the tripod here. If we start with y equals x, and this is roughly y equals x, of course it goes on forever in both directions, hence the arrowheads in both ends. The domain, we'll take a look at the domain. So that is x is an element of all real numbers. Range, we saw from the first page, y is an element of all real numbers. Intervals of increase, from negative infinity to infinity. Levels of decrease, or intervals of decrease, none. Location of discontinuities and asymptotes. Okay, there are none. Zeros, x equals 0, and y-intercepts, y equals 0. Symmetry is odd, as we just found, and then behaviors as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches negative infinity. Okay, so that's the first table there, or the first column of the table of properties. Then we'll go on to part B. And we see that we have a parabola with the vertex at the origin. And so we'll go through the same things again, the domain and range. Pencil is about to break there. So the domain, x is an element of all real numbers. The range, y is an element of all real numbers such that y is greater than or equal to 0. We'll take a look at the zeros and intercepts, y-intercepts. Okay, so the zeros, or the 0 in this case, x equals 0, and the y-intercept, y equals 0. If we look at then part 3, which is intervals of decrease and increase and decrease, so we look at we look to see, as we go from left to right, we travel along the curve from left to right, we see that the graph is decreasing at first, and then it starts increasing. So from negative infinity to almost 0, it's decreasing. Oh, sorry, I put that the wrong way. I usually go from left to right also. So that would be from 0 to infinity, it's increasing. And then the interval of decrease is from negative infinity to 0. For part 4, which is the discontinuities and asymptotes, we take a look at here. The graph is not approaching any horizontal asymptote, there's no vertical asymptotes, or are there any breaks or discontinuities, so there are none in this case. Part 5, symmetry. Well, we can take a look again, f of x equals x squared, so then we first of all put in a horizontal reflection in the y-axis. So that's negative x all squared, and we simplify that, we get x squared, which is the same as the original, therefore it has even symmetry. And for part 6, end behavior, take a look at the graph as x approaches negative infinity, as x gets really big in the negative direction, and as x gets really big in the positive direction. Where does this graph go? So as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches infinity. Okay, so now we'll transfer that information over to the table.